Okay. Okay. Carry on.
All right. You able to hear me okay?
Yes.
Okay. All right. Hello, everyone. I'm Harsha Tadiparthi, and I'm a specialist senior solutions architect covering analytics at Amazon Web Services. And I'm based off of Boston, basically west of Boston, and close to the Worcester area. And, I've been here for about 6 years now. In AWS, I've been roughly a little less than 3 years. Most of my background has been within big data space, but prior to that, a lot of integration, platform engineering, etc., over my roughly 15 years of corporate career. So with that, let me begin sharing my screen and we'll get started.
And if you could let people know if you'd like questions held, or whether you'd like, people just to jump in with questions, that helps.
Okay, great. Yeah, by the way, this is my first time, so thank you for that. So I would appreciate holding those questions till the end. I would give it enough time, probably leave last 10, 15 minutes. So how do you typically do it? Do you pretty much cut it at the top of the hour? Or is it okay to go a few minutes fast?
We're pretty chill. So we often cut it at the top to leave time for questions.
Okay.
But we're all about the chill.
Okay, so roughly have about 30-40 minutes before I'll pause for questions. I'll try to wrap it up by then.
Okay,
yeah,
sure.
And just know that top of the hour, people might start drifting off. I mean, not drifting off, leaving. That's when people start to depart. So this just be aware of that.
Yep, fair enough. All right, you able to see my screen?
Yes.
All right. So let's wear our imagination hats for a moment. Imagine you're lost in an ocean for quite some time, say 24 hours or so, and you have absolutely nothing with you. The ocean is serene with blue sky, mild but warm sea breeze going across your face, and there are sparse white clouds at far distance from you. You wake up in the morning and miraculously you find land. What is the first thing you look for? I would argue the chances are high that you will look to find pure drinking water, which indirectly came from this ocean of water. It is not much different than many organizations that are lost in ocean of data, looking to find valuable insights from that data. AWS Lake House helps these organizations harness the power of the ocean of data they have and turn them into insights. And for those of you who joined late, I'm Harsha Tadiparthi, Analytics Specialist Senior Solutions Architect covering US Northeast. And join me today to learn how AWS Analytics helps you turn data into insights using Lake House. So I have a quick poll for all of us. If you can actually use the browser or SMS to text to this number, we'll get the poll page, and I'm going to actually share the results as well as you speak. Let me also put this in the chat for those of you to make it easier to click the link. All right, there's the chat. And let me activate and full screen. I'll give roughly about 30 seconds for us to see how people would vote. There's an even split so far. All right, 5 more seconds. All right, roughly 50%. Next question is, have you used any of the following AWS analytics services before? Another 15 seconds.
Again, this could be a multi-select.
It could be, you're right, good point. At that point, what's the most that you used? All right, a lot of people actually use between AWS Glue and Elasticsearch. Well, I didn't expect Elasticsearch, but I'm glad to see that. And there's a good amount of Redshift as well, so that's great. And let's go to the next question. Well, let's see if you don't know it, just please feel free to guess it. A lot of S3 to begin with, and some SQS as well. EC2 is coming up in another few seconds, 10 seconds. All right, EC2 is going up a little bit. All right, so it's actually SQS, which is launched in 2004. And S3 is actually launched in 2006, March timeframe, and then 4 months later is EC2. And Lambda is 2014, didn't come in way farther than that, and then Redshift is 2013. All right, good job, well done. Let's get back to our slides. So data volumes are increasing at an unprecedented rate, exploding from terabytes to petabytes and even exabytes. And traditional on-prem data analytics solutions do not scale to these volumes of data because they don't, they're too expensive and they can't scale enough. And we hear from companies all the time that they're looking to extract more value from their data, and they struggle to capture, store, analyze all of that data generated by today's modern data platforms, and they struggle to do that. The data is growing exponentially, coming from a variety of news sources in an increasingly diverse set of formats that needs to be securely accessed and analyzed by several people in the organizations and basically democratize that data. So against this backdrop of increasing data volumes and the desire to get the right data to right people, last year has shown us the need to prepare or need to be prepared for change. We can't predict the future, but you can put in place the infrastructure and the tools required to adjust to changes as quickly as possible. There are 2 great examples I'd like to share. One is Moderna. Moderna was one of my customers last year, and they're based off of Cambridge, Massachusetts. And Moderna is founded in 2010 with the promise of the mRNA science to create novel medicines and such as the COVID-19 vaccine. And bringing new drugs to market would typically take a decade and would cost in excess of $1 billion or more. Moderna runs their drug design studio on AWS, this highly scalable, compute and storage infrastructure to quickly design mRNA sequences for protein targets. And they use machine learning to optimize those sequences for production so that companies' automated manufacturing platform can successfully convert them into physical mRNA. And Moderna is using Amazon Redshift for simple, cost-effective data warehousing to avoid silos and establish a single source of truth for company data. I'll cover that more about Redshift in a little bit, but Moderna used Redshift along with other AWS technologies to help data scientists and engineers aggregate results from dozens of experiments that run queries on large volumes of data and share insights to refine their design and production cycle quickly. Wire has a similar success story with AWS Analytics. They had to create 20 times more number of ventilators in 6 to 7 months to meet COVID-19 demand. And they were able to deliver that using AWS. Again, they used Amazon Redshift and other AWS analytics services to meet the demand. So let's talk about how customers are evolving their data architectures to analyze vast amounts of data in an easy and cost-effective manner. Many companies are taking all their data from various silos and aggregating all that data in one location, what many call a data lake. And to do analytics and machine learning directly on top of that data, and at other times, these same companies are storing other data in purpose-built data stores, like a data warehouse, to get quick results for complex queries on structured data, or in a search system for analyzing log data and to monitor health of production systems, etc. As we see more and more customers using both data lakes and these purpose-built stores, they oftentimes need to move the data between these systems. For example, customers move data between the data lake to purpose-built stores, from those stores back to the lake, and around the perimeter where you see those purpose-built stores, they need to interact there as well. So it's kind of like how successful baseball team needs to be able to play inside out, outside in, and around the perimeter. To enable themselves to get the most out of their data at any scale, customers are rapidly modernizing their data architectures. So to achieve that, customers are building data architectures with 5 key tenets. Building a modern data architecture that allows them to rapidly build a scalable data lake using a broad and deep collection of purpose-built data services that provide the performance required for use cases like interactive dashboards and log analytics, and enabling themselves to easily move data between data lake and the purpose-built data services. Setting up governance and compliance in a unified way to secure, monitor, and manage access to that data. And finally, choosing cloud services that give them low cost without compromising performance or scale. We call this modern architecture, the cloud-based architecture, the Lakehouse architecture. It's not, what's important to note is it's not just about integrating your data lake and your data warehouse. It's about using your data lake, your data warehouse, and all your purpose-built services into a coherent whole. So let's talk about what a Lakehouse architecture looks on AWS. It starts with Amazon S3. Customers have been building data lakes on S3 longer than any other cloud provider. And today, more data lakes run on AWS than anywhere else in the world. And they use Athena, which is an interactive service to analyze all their data. In addition to data lake, customers use a combination of our purpose-built databases and analytics services like EMR, Elasticsearch, and Redshift, which is basically picking the right tool for the right job to get the high performance and scale at the lowest possible cost. And to move their data between these systems, they use AWS Glue, our integration service, which is a serverless data integration service. And finally, they use Lake Formation to manage the security and governance of all their data, regardless of whether it sits in the data lake or in the purpose-built stores. And in all these cases, we've invested heavily in offering the best price performance out there. So let's dive in by discussing scalable data lakes. Data lakes makes it easier to gain insights from all of our data by providing a single place to access all that data in an open source standards format like Parquet, ORC, etc. And AWS has been helping customers with to build strong foundation for data lakes with services like S3 for years. And there are tens of thousands of customers running data lakes on AWS than anywhere else. And we have success stories virtually from customers in every business domain. Whatever you're looking to do with your data, AWS gives you the broadest and deepest portfolio of purpose-built analytics services. Remember when you were a kid, or remember the time when your kid has played with Lego blocks? And remember how those simple blocks of squares, rectangles come together to build those complex structures such as Skywalker's X-Wing fighter from Star Wars, or a beautiful Golden Gate Bridge. No matter how complex the task is, the key is integrating these blocks together. Just like these simple blocks of squares and rectangles come together to build those complex structures, AWS offers purpose-built analytic services that can be pieced together to solve any of your complex analytics problems. We don't believe in a one-size-fits-all that some of our competitors market as simplicity, but customer success stories like the ones I've shared earlier about our purpose-built services speak to themselves the value our analytic ecosystem has added. Let's take a bird's eye view of the AWS Analytics core services that we commonly see most customers use and where it fits within our AWS ecosystem. And I just wanted to also highlight that we have more services than just the ones listed here in these categories, but we've actually highlighted only the ones that we call the core services in a layered approach, just for you to have a quick view of a bird's eye view of this ecosystem. No matter what your analytics use case is, we have purpose-built services that cater to their need. You certainly don't need to use all of them for every use case, but pick the right tool for the right job. So let's look at interactive service. Athena is an interactive SQL querying tool that helps you query data in S3 as it arrives, which can be in various formats such as JSON, CSV, Parquet, etc. And you pay as you go with about $5 per every terabyte of data scan. And that's prorated, obviously. So some of the noteworthy features with Athena I'd like to highlight are Athena is ANSI SQL compliant, fully serverless, and you can easily and directly start querying the data without moving it from where it is landed in S3. Great for self-service data exploration use cases. It has JDBC ODBC compliance, which allows you to use against any BI tools for you to query. It allows federating your on-prem data sources or AWS data sources, such as RDBMS, NoSQL databases, etc., and query them from Athena. And another noteworthy item is to be able to run machine learning training or inferences using SQL from Athena against the SageMaker endpoint. SageMaker is a machine learning and is a fully managed end-to-end machine learning platform from AWS, for those of you not familiar with SageMaker. So up next is big data processing. Amazon EMR is a fully managed service that makes it easy to process petabyte scale data using latest open source big data frameworks such as Spark, Hive, Presto, HBase, etc. And EMR runs directly against the data stored in your S3 data lake and allows you to separate your compute and storage, thereby being able to scale your compute based on your computational requirements and the storage needs. Today, EMR is the fastest place to run Spark workloads than anywhere else. It's 1.7x faster than Apache Spark 3.0. Amazon EMR runtime for Apache Spark is a performance optimized runtime environment for Spark that is now active by default on Amazon EMR clusters. And we were able to achieve this speed by still maintaining that 100% Spark API compliance. And that helps you perform those accelerated Spark workloads at the lowest cost. And if you're switching from Spark either on-prem or somewhere else, you do not have to do anything special to make use of this additional speed. We've done that all under the hood with full transparency for your workloads that they automatically take advantage of it. Amazon EMR runtime for Presto is a performance optimized runtime environment for Presto that is available by default from Amazon EMR release 5.30 and higher. And using our TPCDS tests at 1 terabyte scale factor, we were able to see that the Presto on EMR is up to 2.6x faster compared to Apache Presto. And EMR supports our Graviton processor-based instance types, which are proprietary Amazon manufactured chips. And they're basically known to be faster in price performance ratio. And roughly on an average, we've seen 11.5% performance improvement at 25%, 0.7% average cost reduction. So for those of you who use EMR or plan to use EMR and do not use Graviton, you're basically leaving money on the table. Until now, you had to choose between EMR on EC2 or self-managed Spark if you're running Spark workloads. And for those customers who've been standardizing on containers, they've asked us to support a managed EMR on containers. And that's when we launched recently Amazon EMR on EKS, which is fully managed. EKS is a fully managed Kubernetes service. And if you're familiar with our serverless containers, Fargate, you can also run EMR on Fargate. And today, as we launched, it's only available for Spark workloads. And that's the only thing that you'll be able to use today, and not other workloads within EMR. So I'd like to, if you already kept your browser open, feel free to just keep that open. I'll have a couple additional knowledge check poll questions coming up your way. All right, let's go to the next one. Which of the following is not a key tenet of a lakehouse architecture? All right, none of the above. Unified governance. I repeat, it's not a key tenet. That's the question. Maybe some are thinking it could, one of these are, but just making sure. Few more seconds. 5 seconds. Perfect. Most of the people answered it right. The key tenets are scalable data lakes, seamless data movement, purpose-built data stores, unified governance, and the one that's not on this list is performance and cost efficiency. Let's go to the next question. EMR is the fastest place to run Spark workloads. How much faster Apache Spark 3.0 run on EMR compared to same Apache Spark version? I see people did remember the numbers. I see a lot of 2.6x and 1.7x. 5 more seconds. It's 1.7x. Most people got it right. Presto is the one that's 2.66 faster than open source. But I'm glad you're able to actually remember that and answer it right, at least most people. Let's get back to the slides. So let's look at data integration service with AWS Glue. So AWS Glue is more than just a data integration. It also has a strong place within big data processing. It's fully serverless. But it has a lot more capabilities from an integration standpoint. And AWS Glue is fully serverless and makes it easy to prepare data for analytics, machine learning, and application development. Glue provides the capabilities for data integration so you can gain insights and put your data to use in minutes instead of months. And today it is supported with serverless Python and Spark, PySpark or Scala that you can actually use. We recently launched Glue Studio, which is a hybrid visual ETL authoring tool for developers to use the best of both between visually authoring ETL jobs without writing any code to writing handwritten code for complex ETLs. So it also has that visual interface if those of you who are not familiar with it. And Glue has the ability to scale automatically when you select the DPUs, which is a measure of the amount of compute for core 16 gig memory. And you'll be able to use multiple of those DPUs to scale horizontally. And again, it's serverless and no servers for you to manage. So we see customers use Glue in a variety of use cases. I'm not going to cover all of those, but I'm thinking some of you who've already mentioned earlier in the poll that you are using Glue, you certainly fit in one or more of these use cases that we commonly see. We see customers migrating from on-prem to AWS or trying to modernize data integration solutions. They've invested a lot on ETL tools on-prem, and when they switch to AWS Glue, they find Glue to be 7x cheaper compared to those on-prem options. And because there is there's no proprietary code, it's basically based on Python and Spark code, there's no vendor lock-in as well. And customers often moving from cloud, trying to do their own DIY Spark on cloud, managing those Hadoop servers, etc. They're able to save up to 5x moving to Glue, and it reduces up to 4x overhead in their maintenance when they switch to Glue. And again, there is no vendor lock-in, and customers are able to use Glue without the penalizing expensive licensing that those ETL tools that they're used to in the past, and leading to up to 55% cheaper compared to other cloud providers. I touched upon Glue Studio, which is a visual authoring tool. I'm going to skip this slide. So one important feature I wanted to talk about, or service I wanted to talk about within the Glue ecosystem, is Glue Data Brew. Oftentimes, the analysts and data scientists, more importantly, spend most of their time, up to 80% of their time, on data preparation, in preparing for their machine learning or advanced analytics use cases. So they basically call that feature engineering. And with AWS Glue, using a visual interface without writing any code, they're able to simplify and improve their efficiencies in doing data preparation by up to 80%. That's no joke. They're able to use the graphical interface, using configurations, connect to any sources they have available, and use one or more of the 250 transformations we started to support originally at GA, which is about 4 months in now. And they're able to perform data cleaning activities, which is typically the first step of a data science exercise. And they're able to find this in a much nicer view that they're used to, like in a spreadsheet type of a view, and apply those transformations in a drop-down type approach, and then build recipes which can be reusable. So they can take that, do it one time, and then apply it to further additional jobs or additional users that they can collaborate and share with. And then we also provide the capability to run data profiling on the data. So oftentimes, when data scientists work on a large amount of data, they quickly want to understand, how many unique values are in a column. They quickly want to know if there are any null values in a column. They like to know the median value in a particular numeric column, right? What's the average of these columns, etc. A lot of those we make it available in a histogram and profile the data ahead of time, so that the data scientists can quickly know that they don't have to write additional code or the queries to know those type of metrics that are very important in working on feature engineering. And then finally, we also supported data lineage, so that they know how that data has transformed over a period of time, from when it was raw all the way up to when the model got fed with that data. So just wanted to give a good separation between how you think about Glue Studio, which is designed for a persona of ETL developer, versus Data Brew, which is designed for persona of a business analyst and data scientist, right? And the typical activities that they help with. Right? I'm not going to read through each of these, but it'll be, I'm thinking it'll be very valuable for people to know. So bringing Glue, the data integration ecosystem and its services together, just think of any sources on the left-hand side. It can be your on-prem or AWS services. There are several connectors. We actually created a marketplace in Glue, and you'll see that in Glue Studio. The marketplace is for you to find a connector. There's a connector to connect to Google, Google's BigQuery, and you'll be able to ingest data from Glue and from GCP into AWS using the Glue connector. Similarly, we have connectors for Elasticsearch, where you can write data, transform the data in Glue and write it to Elasticsearch. And there are these type of connectors marketplace that you'll be able to leverage more and more connectors to data sources that you didn't have seamless access in the past. And you bring that data, if it's a streaming data set, we also created a schema registry that makes it much easier for stream data to be conformed in your Spark streaming code. And customers like to build a catalog, which helps that central catalog across the organization and leverage that across their transformation analytic activities and author the data or transformations using Glue Studio, unit test those that they've built in Studio using dev endpoints, or even using a notebook experience, and then feature engineer or perform the data preparation for analysts using Glue Data Brew. And within the Lake House, when customers try to write that data, it can go into any of the targets, right? The transformation that's done in Glue can be loaded into an enterprise data warehouse Redshift, or it can be written into a log analytics solution like Elasticsearch, or even as simple as your on-prem database. Any of that works. However, now from a Lakehouse architecture that I've shared earlier, it's important to interoperate between those periphery of services here that you are seeing, as well as bring that data between data lake to those different services. So for that, we've launched a service called Elastic Views, Glue Elastic Views recently, and that's a service which helps you bring the changed data capture from any of these sources. At launch, we're doing it from a DynamoDB to targets such as S3, Redshift, Elasticsearch, and RDS. But we certainly have other services that we published that are also in this, that also follow soon after the GA. Now, let's focus on data warehousing. Amazon Redshift is a petabyte scale, fully managed data warehouse built from the ground up for the cloud. And Amazon Redshift is the fastest, or I would say 3x faster than any other cloud data warehouse that customers typically come across in the cloud. And they're able to perform the performance efficiencies at 50% cost compared to other cloud data warehouses. And I wanted to quickly touch upon some of the recent innovations on Redshift, and I'm not going to dive deep on this just given the time, but I wanted to highlight quickly the ones that customers get excited the most. Data sharing allows customers to use multiple Redshift clusters where one can be a producer and it'll produce the data, and others are just consuming the data, and they can be up for 1 hour a day, 4 hours a day. There can be a BI team that uses it just to run reports, data scientist group that just runs data science operations like data preparation, etc. And they can be those as many number of Redshift clusters for those brief periods of time. Amazon Redshift ML is a very interesting and important feature for those SQL savvy resources who are not machine learning, data scientist type resources, not fully familiar with how to use and what machine learning model to use, etc., they're able to use SQL and build machine learning models using Redshift ML, which provides them an auto ML feature where they send data and we using our advanced machine learning capabilities, the best machine learning model that fits for that data. And you're able to then use it against a SQL interface for running inferences or training your data, etc. Aqua is an innovation which is nowhere else to find in the world, which is very unique to Redshift, that provides up to 10x faster than any other cloud data warehouse. And what's under the hood is computational storage, the concept of computational storage devices. For those of you who are not familiar with computational storage device concept, just think of as simple as, if you have a server, it has a CPU, right? And you perform your computation, your scans and AGs, and your CPU is actually the one doing it. You do encoding, encryption, etc. Your CPU is the one doing. Now think about, what if I have storage devices, and there can be hundreds of storage devices where I put compute on each of those storage devices, very close to it, right? So at that point, now I have data on the disk, so data is not moving up from the disk to the server CPU anymore. It can actually process those individually on each of those storage disks with the data that the storage has, and perform those scans and AGs, and filters and all that. It's extremely faster because of that approach, and it's very unique in AWS. And Redshift is really going to perform at up to 10x faster because of that feature. And customers looking for operational analytics, such as log analytics, they look to Amazon Elasticsearch. And Amazon Elasticsearch is a fully managed Elasticsearch service, which is basically supported from Open Distro, which is an open consortium for Elasticsearch. Primarily, a key contributor is AWS, and there are obviously several other partners. And Amazon Elasticsearch is a fully managed service that helps you quickly spin up a search service within minutes and be able to scale horizontally or obviously vertically using any instance types that you select. And offer significant cost savings up to 90% because of our unique feature called Ultra Warm, where in a traditional Elasticsearch cluster, if you have lots of data that you want to persist, like indexes, log indexes that go 1 year, for example, you have to pay for the storage, which can only come in at the cost of compute. You cannot separate those two together. We've innovated that with UltraWarm to separate those two out. We use a managed S3 storage from which the data comes in at a lower cost, only when required, to the compute layer, which is going to be separated out. So there's a hot cache on the compute. Think of that. Because of that, it's cost effective and saves up to 90% on those hot storage tier costs for customers. And it's fully secure, compliant, and an important thing is how tightly integrated with AWS services such as for streaming with Kinesis or Glue, etc. It's very coherent in its way to interoperate. And when talking about real-time streaming, a lot of customers use Kinesis when performing stream analytics. It has data streams, which is a pub sub, simplest pub sub, and Firehose is a data stream delivery mechanism to write data into a target, such as Redshift, Elasticsearch, S3, and Splunk. And then the data analytics service helps you perform real-time transformations, aggregations, window functions, etc. on your stream, and even joining that stream with lookup data that you may have elsewhere, and do that just using plain SQL and also as well as Apache Flink. Video streams, as the name suggests, it supports analyzing streams of videos from several video devices. And it can also help audio and radar as well. It's because it's binary encoding. And then we also supported managed streaming for Kafka, which is basically a fully managed service. The rest of the Kinesis services are fully serverless, just so you know. And you can bring in your Kafka APIs and or code that's basically using those Kafka APIs on-prem or elsewhere, and they should be able to seamlessly run in AWS. Now, when you use these services, one of the most important pieces in modern architecture is for customers to ensure there is governance when working across these services. And that's where AWS Lake Formation makes it easier by providing a single pane of glass to enforce those access control privileges for the data, such as whether the data is accessed through Amazon Redshift or Athena, or even QuickSight, which we'll talk about in a little bit. And no other analytic provider today gives you the ability to secure your data with the fine-grained access control and governance to manage all of your data from and audit from a single pane of glass in the cloud. And AWS is committed to building the best-in-breed services across all of our categories. With Lake Formation, it basically enables users when accessing through services such as Redshift or EMR, Athena, and even QuickSight, to be able to use a single pane of glass to define authorization grants on central catalog, which is a high metastore catalog, and define as fine-grained as table level, column level, and even row level security within your AWS account, across your AWS accounts, right? You can do all of that that protects your data in S3 and makes it much easier to do audit management and permission controls. I'd like to leave at least 10 minutes for questions. So I'm going to wrap up in a minute with QuickSight. And QuickSight is a serverless BI visualization service that seamlessly scales from tens of users to tens of thousands of users without any infrastructure management or capacity planning that you need to do. It's the first fully managed serverless BI service that enables you to build dashboards, embedded dashboards that can be within iframe within a browser, and you can enable that at a very low cost of up to 29 cents per user or $5 per user at a max per month. So it's very, very low cost. And we've also added a couple good features. One is machine learning powered insights, which automatically identifies using our extremely battle-tested machine learning algorithms to identify anomaly detection in your data, and also helps you forecast without having to write any code. You just use like a linear graph, and it'll be able to predict what that sales forecast for the next 6 months is. And again, there's no code for you to write. You just enable that, and it'll be able to predict it. And one additional feature that we've launched recently is QuickSight Q, which is basically like Q&A. You type question, and it'll actually create a graph on the fly dynamically for you, a visualization dashboard that you can then publish it. Again, no writing code or no writing any BI dashboard like any other tool. So this slide, I just wanted to leave it for those of you who wanted to quickly see some of the recent launches during reInvent, which was in last December. All right, to recap, AWS Lake House on AWS Lake House architecture in AWS helps you quickly get from insights against all your data to all your users, and will allow you to build for the future, so you can easily manage your business use cases, no matter how complex they are, and enable your users as the data becomes available for them. All right. last knowledge check. You can continue to use your same browser if you have it open, or text it to this link. I will just enable that. All right. Which of the following native AWS services is best used for interactive SQL analysis? Everybody's paying a lot of attention. I'm very impressed. A couple more seconds. Very good. Athena it is. Which of the following services is best suited for serverless big data processing? My apologies on the processing spelling. All right, few more seconds. Again, I highlight serverless big data processing. Three more seconds. Well, for those of you who answered EMR, it's basically fully managed service. It's not serverless, but you got it right for the big data processing part. But this question is essentially tricked you, perhaps. It said serverless. So the answer is Glue. Redshift is also something that you can use for big data processing, but that's for data warehouse type, very fast performance. And obviously QuickSight is a BI tool, and you got it right for Athena. All right, last question. Which of the services interested you the most that you like to have a further deep dive? All right, a few more questions, a lot of interest in Glue. That's great, that's good to know. All right, some Amazon Athena and Kinesis. All right, 2 more seconds. All right, it's good to know a lot of you are interested in learning more about Glue, and then Athena and some Kinesis for real-time stream processing. All right, with that, I'm going to stop here and take any questions.
So I'm gonna jump in and say it'd be great to have you describe an example of using all this, or show some, maybe show some data from a couple different places that get mushed together and then queried.
So the question is, you want to learn like how these different services can get data from a variety of sources, and go ahead.
I was just hoping to see an actual example. That makes it more concrete. But
oh, I see. Well, I have some reference architectures and customer examples as well, which I haven't opened that. I can actually share that. Is there a way to send across to people as a follow-up? I could send a PDF with some architectures and customer examples also. That actually helps people to envision how that can be done.
Sure.
Post to the,
Go ahead, Ken.
No, I was going to say, you can just post to the meetup group to the discussion section for this particular talk. Would be a good place to put that.
Okay. All right. That'll be great. I'll do that. Thank you.
About EMR, and maybe I'm not totally understanding what EMR is meant to do or how it works, but if you want to do some distributed processing, what are some of the limits? I mean, does EMR have like a memory limit per job or something along those lines? Because we're doing on-prem distributed processing, but the per node or per job memory requirements are non-trivial.
Sure. So EMR basically is going to help you separate storage and compute, unlike on-prem where you have your compute and there is a storage that's attached to it. The only way you can scale on-prem is to purchase a new server that comes with a set of disk drives and then the CPU that comes with it. Now, a lot of the big data problems recently over the years have been evolving with more and more data. So your storage is increasing, and obviously it's not at the same rate that your compute is, but it's important to do that separation. So within EMR, we allow that to happen. We make you use S3 as a central storage. And then within EMR, there are about 119 instance types. So you can pick between 4-core CPU all the way up to, I think the highest one is 128-core CPU or 256-core CPU, one of those, right? So that high amount of cores as well as memory, you can go all the way up to, I think the last I've seen is about more than a terabyte in memory. So you can pick with transient clusters in nature, which means there's no data that's persisted on these servers. So you actually can bring up these servers of different types that can come in, process a job, and then they go down. So you have one job which requires very large amount of resources, come in and use those larger instance types and complete that job in 30 minutes, and then have another, which could be a smaller cluster that's performing another job, and you're paying costs separately. There's no single cost structure. You're paying by what you use. So those are some of the advantages, and especially valuable when you're using Spark or some of these technologies.
Okay, and a follow-up question to that, because so I'm used to distributed compute where you can launch a series of jobs with dependencies between them. So it's a cluster of jobs put onto the cluster, and EMR that's what it's set up to do. It's distributed.
Got it. So
a job management engine.
Right. So there are two things. One is the job orchestration and job execution. The other is actual compute. So EMR is the actual compute. The orchestration is, we have two services that are commonly used. One is AWS step functions. And using the step functions, you orchestrate, you define the dependencies, it'll create the cluster, complete the jobs, wait for another upstream, and then it'll finish the rest of the jobs and then close the cluster, right? So you do that with step functions. There's also something called Apache managed service for Airflow, and that's a fully managed Airflow service. If you're familiar with Apache Airflow, it's also very much similar in that concept. You define using Airflow and the AWS SDK APIs, build your orchestration, and then it'll be able to manage that dependencies for you from there.
Do either of those, so I'm familiar with Slurm, do either of those compare to that?
Slurm, I've not heard Slurm before.
Okay.
So that would be like CFN cluster would be maybe more of a comparison. I think AWS renamed or productized CFN cluster, but that's more of a Slurm kind of thing.
Yeah, so
Okay.
Slurm has the same functionality as like your Kubeflow, etc. So there is some functionality parity between Slurm. It does the distribution of ML jobs, etc. So
Sorry, I couldn't hear that. What was that?
apologies, I was eating at the same time. Sorry about that. No, so the context in which we've heard Slurm, it's you have traditional ML jobs that are on large data platforms, big data platforms. They're the workflow orchestrator, job scheduler is Slurm. So the corollary to native constructs within AWS or public clouds are, if you're running, say, cluster jobs on Kubernetes would be Kubeflow.
Hi, this is Sam. Can you talk a little bit about the AWS managed Airflow service? Things like what version of Airflow do you guys support? And if somebody already has a an on-prem or an EC2 with Airflow installed, how does migration to the Airflow AWS managed Airflow service happen?
Yeah, unfortunately, I don't have a lot of visibility into that migration aspect and the version. I'll have to go back and check, but I can actually send you a follow-up using the discussion board I learned earlier. I can send you some details as a follow-up if it's okay.
That works. Thank you.
And Sam, I would say that the positioning of Airflow, I don't have enough, I don't have any firsthand experience, but the positioning of Airflow is to be able to do what you want to do, just like they've done with many other services where they take some open source software, they manage it so that you can move your workloads onto them. It's kind of why they're doing it. So I would hope and think it would be pretty straightforward.
Thank you.
Okay.
Sure.
Hey, Harsha. So Harsha, I had a question about, so we've been building data lakes in AWS for quite some time. We have lake formation. There's also data lake as code is this open source project. And there's a whole bunch of others. And just in the same way that there's a lot of choices with analytics products, even within like, once you say, okay, fine, but now I have a lot of choices of how do I build a data lake. So, and it changes every like 4 months. So like, do you have a sense like what is today, if I were to start something from scratch, what is the most kind of consensus on like how people should be building data lakes today with the current various open source projects as well as AWS versions of things, and lake formation and such?
Yeah, it's an excellent question, I think, given, and somebody said, great question. Well, I'll tell you this, right? What we came out to do is to not give you a one-size-fits-all approach. Now, what that means is if you are doing a stream analytics type solution and trying to bring that stream data into your data lake, you would use our stream services. If you need a serverless Kinesis, right? If you need managed open source that you want to take that code and later go to another cloud, etc., managed Kafka. So my point is we've created those purpose-built services. Now, from a data lake ingestion, if you're talking about like an ingestion standpoint, bringing all of that coherent way of managing the security, cataloging, governance, I would say the future, at least, I'm not going to talk about the roadmap, but the way we started with the lake formation governed tables, the way we started integrating lake formation security features, etc., that lake formation is a great place for you to at least start adopting it if you're not already done so. Now, I talk about governed tables if you're not familiar with that. The concept of the governed tables is to simplify your data storage layer without having to manage the complexity of incremental processing for updates and deletes, making it more transactional in nature. There's a lot of resources you spent earlier in trying to stage the data and then create the latest view and things like that. And we're trying to create a better standard from there. We sort of started that with Hoodie. And then Hoodie is an open source. It's on EMR only. It's not an AWS managed service. So we basically started with this governed table, which is essentially going to be integrated across these other services. Now, as we launched recently, it's basically got 2 APIs. One is batch API. One is a transactional API. So you say, if you use a transactional API, you say, I want insert, update, delete, and you call the API, and we manage that for you under the covers. And if you use Athena to query that governed table, or Spark to query that governed table, we give you a transaction. So it uses a transaction, and it automatically maintains MVCC. So that's the whole future that we like our customers to start thinking about, right? It doesn't have all the bells and whistles today, but governed tables is I think that's where we at least recommend all our customers to start thinking about.
So I may have missed, I'm not sure I'm catching that keyword. govern tables? I'm missing.
Yeah,
What-
that's right. Governed tables.
But that's not a proper name. You're just saying that.
No, it's a
you're
proper
just saying
name.
that- oh, it is. So
It
okay.
is.
Maybe you could post a link to that in Slack.
Yeah.
Or
It was
in, the
recently
chat.
launched in reInvent, so not a lot of people are familiar with it. It's called the Lake Formation Governed Table. It's
Oh,
yeah.
okay.
So-
Now I'm
so
with you.
Is it a part of lake formation or is it a,
Yes,
yeah, okay.
it is. It is.
That's clear enough.
It's basically an integrated format. If you think about, if you're familiar with, I don't know if I'm allowed to talk compete here. I'll skip talking about compete. It's okay. I'm trying to draw an analogy with what you know already. Okay, so if you're familiar with Aurora, okay, so Aurora has its own storage layer, and it basically manages that data lifecycle and manages the copy, etc., for you. And you use the API, right, at the back end, which is basically MySQL or Postgres based. Now with governed table, we still use your S3 bucket, but we manage the metadata that's outside of S3 now. And that metadata is going to allow us to quickly and in a very rapid way capture your incremental data. And even if you're writing small files with a stream type of workload, we do that checkpointing frequently and do that compaction frequently, and you're able to get a better performance out of that. And we're managing that all in a governed way because you are not managing that for that data.
So I don't need to use Kinesis to bundle up all my little S3 files. I could just skip that altogether and just use governed table.
The question is, you could use Kinesis Firehose to buffer all that, and
Well, normally I would do that, but it sounds like I could skip that in what you're
Yes.
describing, which would be
yes,
cool.
you can, and so there are two sides to it, right? So one is, yes, you can do it. However, should you do it is based on how much data volume and velocity you're getting. If you're getting large enough velocity that you can actually get 100 megabytes of file in S3 using Firehose every 50 seconds, 100 seconds, or 500 seconds, I would say, at least for now, that would be a preferred approach, right? Because you are writing larger files, and those are going to be good for a performance standpoint. Now, if that data also has updates, usually a lot of that stream data doesn't have updates. If they do, then governed tables would be the best place to go.
Got it. Okay, cool. Thanks.
Yeah.
Anyone else?
Is a governed table somewhat similar from an analogy standpoint, like a view on a relational database? So you've got multiple data sources behind it, and you're creating some sort of overlay on it, or am I not, just from a conceptual standpoint?
Yes, no, that it's not close to that. So from a conceptual standpoint, think of it as a catalog table similar to a Glue catalog that's today, except that instead of Glue maintaining only the metadata for you, we're actually beyond the metadata management, also managing the life cycle of the data. You can do time travel. You can just delete one record of your entire data set, and you don't have to take the hit of overwriting all your S3 data, partitions, etc. So there's a lot to the governed table, right? GDPR is a great example.
Is it a kind of CDC process?
It makes CDC easier. It makes CDC a lot easier. It's
Okay.
been one of the biggest challenges in data lakes, right? You spend a lot of resources on CDC, but we want you to spend a lot of resources on actual computation of machine learning or aggregations than just the CDC processing. So that's where the rubber meets the road with Glue governed table, with Lake Formation governed table.
Is it similar to what the Delta format is? Does the governed table support CRUD updates and deletes?
The Delta format, what Delta are you referring to? Just the data Delta, or are you referring to the
Spark Delta format?
with Databricks?
Right. Which
Okay.
is now open source.
That's where I was trying to avoid talking competition here, but I would simply say maybe similar. Think of it maybe similar. I
got it.
wouldn't be able to answer
can-
further than.
I can read between the lines. Thank you.
All right.
Could you talk a little bit about lake formation, how lake formation integrates with Redshift? I understand you could have external Redshift external tables and query them using Redshift Spectrum. But how do the permissions you specify in lake formation, the IAM users or groups you create in lake formation, how do they square off with, let's say, the Redshift cluster IAM role itself?
Yeah, so today, as it stands from a Redshift, Spectrum, and IAM user group standpoint, it's not fully integrated just the way we do it for Athena, right? It's not as simple as that. You still have to rely on the IAM role. And within your Redshift cluster, use a external schema. And when defining it, use a IAM role chaining. And IAM role chaining then allows your users and groups within the IAM or the Redshift cluster to be able to isolate and separate those user access between those groups. So sort of that multi-tenancy way. I have a blog I've written on that. I'm happy to share it with you if you're interested in learning.
Sure. Yeah, I would love to get more information on that, because we looked at lake formation and that was one of the reasons we didn't jump right into it.
Yeah, that's right. It's today, even still today, it's not yet integrated with the users for Redshift.
Well, what keywords should I search for your blog?
Search for Redshift, IAM role chaining.
Oh, got it. Thank you.
Yeah.
Okay,
So
so we're
these are
going
all,
to.
these are all great. Go ahead, Brian.
No, go ahead, Yaro.
I was going to say, these are all great questions, and it sounds like everybody's really interested, and it sounds like there may be more questions, but in the interest of time and for everybody's sake, is there a place that we can get a hold of you if folks want to follow up or to reach out later on and find out more information? Do you have a Twitter handle, a Slack channel that you prefer to look at, or a contact?
Oh, good question. Yeah, I had people reach out to me through LinkedIn in the past, but this is my first time in a meetup forum. So I do have a Twitter handle, but I haven't been actively using it.
Okay.
So I would say start with the LinkedIn handle, and from there I have it open for anybody to send in send in messages. So I'll try to answer at my best availability, and based on that, I'll see in the next meeting, maybe if I need to switch to Twitter or something.
All right, excellent.
Okay,
Thank
great.
you very much.
Great, thank you.
Sure.
Thank you for giving us the talk. Thanks for the great questions, everyone. I want to remind folks that our next talk is in 2 weeks, where we're going to have AJ, who's spoken to our group before, tackling AWS